Derived types in C++, array, pointers, and reference. Let me jump into the editor to start discussing the derived types: array, pointer, and reference. If I want to store information, a large number of information of the same type. For example, if I want to store uh, IDs of, let's say, 100 people, or 100 students, the ID, suppose the ID is whole number, such as like this: 101, 102, and so on. In this case, if I have to use the variables to store IDs, then I would be creating something like this: ID1, ID2 equals to 1002, ID3 equals to 1003, and so on. This will be very not manageable. This will make the code not manageable at all, because you'll be having 100 different variables storing different IDs, and keeping track of all these variables, and it will also increase the size of the code, and it will be difficult to manage and keep track of all these variables in the uses. So in this case, the array is the tool that relieves you from a lot of trouble, lot of difficulty. I can have an array to store whole numbers. If I have such an array, then I can store these whole numbers in the elements of the array. So we can create an array to store this kind of information using this syntax. You have integer keyword, and you give a name, whatever name you want to give. It should not be the keyword. For example, I can use a double as the name of the array, but it should be something else, that whatever you want. Let me call it I array, integer array, and within this bracket you give the number of data you want to store in it. Let's say it is 100. Now this is a syntax that defines an array. Here in this case, 100 is the capacity of the array, and IArray is the name, and int is a type. So you can store only integer type data in this array, and this array has the elements. The individual units of this array are called elements. They can be accessed using this syntax. So first element can be accessed by having a name followed by bracket, and within the bracket you put something, the value that starts from, let's say, 0. This the value you put here can be the starting from 0, 1, 2, and it can go up to one value, one number less than the capacity, which is 99. That means if you start from 0, total number of counts should be 100. Okay. So therefore this thing I put here is called index. So if I have index equals to 0, and I use that index to access that element, then I will be accessing, if it is 0, then I will be accessing the first element. And I can store the first number into it. I can have another index, or index plus 1. It could be plus 1, or you can just use 1 to store a different number, plus 2, and so on. So we have 4 elements. It is not necessary that you need to fill this array elements, all the array elements. Many times some of the elements may not be used. That gives you flexibility in terms of in using this array, because you may not have a total 100 number of integer items all the time. So if you have, let's say, 4 items and you have capacity 100, then in this case I am using only 4 elements of the array, storing the IDs. Now these IDs, one advantage of having this kind of array is that I can set this data, this ID, in a loop. I can use loop. Let's say I want to set 10 data into it. Right. In that case, what I can do is I equals to 1001 plus I. So this will actually set the first element will be set, because I value will be 0, and after that it will be 1, 2, and so on. So the first element will be set to 1001, second will be 1002, and so on. And now if you had to set 10 elements, then you will be having this 10 number of instruction if you are doing it one by one, or in the if you are setting that this kind of data in the variables, you will have 10 different variables. So but this is a very concise and very convenient code to use, and array actually allows us to use this kind of code. And if I want to display the elements of the array, I can use the similar loop, I less than 10, I plus plus, and I can have a cout statement and display, let's say, one element, let's say element, let me use the name of the array itself, this bracket I close, then the value. So you have this 10 elements which are used, and the data stored in the 10 elements will be displayed by this loop. And I want to display in separate lines, so let me put a new line character here. Let me switch to the terminal to see the output of this code. Compilation, linking, and execution. So we have this data 1, 0, 1, 2, 3 all displayed in different rows. Now if I want to use, let's say, 50 elements, then I can conveniently change to 50. It gives a lot of flexibility. If I want to use, let's say, total 100, I can use 100. Let me give it 50 here. Switching to the terminal, clean up, compile and link, and execute. So now you can see total 50 elements of the array were actually set, and they are displayed. Right? This is the sort of convenience that array provides. Now next type I want to discuss here is pointer. Pointer is a variable that you can use to store address. This is basically a variable to store address, and if you want to, let's say, store the address of let me create a integer type variable int x equals to 16. If I want to store address of x in a variable, then I can create a pointer variable. using this syntax. You need to have a int keyword followed by asterisk, and you give the name of that pointer. This is the statement that creates a pointer named iptr, and you can set it to address of x, and this ampersand is the operator that actually returns the address of this variable x. So this is an expression. When it is executed, it returns the address of variable x. So now iptr is x is holding data 16, and iptr is actually pointing to that variable. And if you want to access this, or first you want to see what is in that variable x through the pointer, then you can have a cout statement like this, and from iptr you need to use one expression, something called dereferencing the pointer, right? So for dereferencing, you actually put the name, and before the name you have to put asterisk. So this entire process is called dereferencing, and since we have dereferencing, so I will put this entire thing here, and then after that I want to set different data through this dereferencing. When you have dereferencing, it will give access to the address of x, and then whatever you do through this expression, the data that will be written to or read from will be from the memory space of the x variable. So if I write 32, and then after that if I do access, then first this will actually check out this data 16 and display on the output terminal, and after that memory space will be rewritten by this overwritten by this value data 32, and this should display the value 32. Okay. Let me switch to the terminal, compile and execute. So now you can see, okay, I think I should have, let me do a little bit editing so that I don't have to see this thing. So let me comment this out for a while, for a moment, because it is preventing me from seeing the output. Switching back to the terminal, clear. Now you can see previously it was 16, this is the value of x, now it is 32, but it is accessed through the pointer, right? So this is these are the terms. I mean, your definition of the pointer, this is syntax. If you want to access the address, then you put ampersand before the name of the variable, and if you want to access the memory through the pointer, then you need to dereference it, like in this case. Now pointer is a very useful, very useful thing. For example, if I want to this name of the array itself is a pointer, so if I, let's say, copy the I array here, iptr equals to I, then the address of the first element of this will be actually stored in this pointer, and if I want to access the data after that, and then it will be the first element of the array, right? This will actually give access to the first element, I mean this data of this array. So let me see that. So you can see the data is 1001, which is displayed here. Now if I want to display all the elements, then I can put this in an array. For example, for let's say int I equals to suppose I want to display only 10 out of this total 100, 50 elements here. So 0, I less than 10, I plus plus. And I could do something like this. uh, let me have this thing here. I Now to access those data you need to actually dereference, but you need to keep incrementing plus I. So this is the pointer syntax. If you increment, then it will actually point to the next element, next integer element after that, and next, and I think that is what happens here. The elements are stored in the next memory space. This is stored in 1 byte, and then this is stored in the next byte. This is stored in the next byte. So if you increment the pointer, address of this element, and it will be the address of the second element. And if you increment that address, it will be the address of the third element. It happens that way. So if the pointer is storing that address, then if you increment the pointer, it will be actually carrying the address of the second element by one step. If you increase by 2, then it will be carrying the address of the third element, and so on. Let me see the output here. In the terminal, let me clear it up. Now you can see the 10 elements are displayed, but it was accessed through the pointer, not through the name of the array itself. So this is about pointer, and the next I want to talk is about the reference. Um, Let me comment this out because I don't want the things displayed when I am demonstrating the use of reference. So reference is something called some nickname or some different name or alias um, given to a variable. Right. For example, if I want to create a reference is for x, that means another name or nickname for x, then I could do using this syntax. You have integer keyword followed by this character ampersand, and give the name of that reference iref. And one thing you need to be careful here is you need to immediately tell the compiler which variable it is actually will be referring to. Here in this case I want this variable to refer to x. Let me call this x reference, xref. So xref is a reference to x. So in the case of pointer, you don't need to set right away like this. You could do you can define and initialize in the same line, but it's possible you can define in one line and initialize in another line. But in the case of reference, you need to initialize on the same line. Right. So now with this, you can access x using the regular syntax. You don't need to dereference like this. So the code looks a bit more pleasing using reference. Right. So this is the data accessed using reference, and this is the data x itself. And if you can also make change through the reference equals to, let's say previously x was 16, so if I change this to 77, then after that if I display the value either through the reference or through x, it will be the same value 77. Okay. Compile linking and execution. So you can see previously xref accessed value was 32, x value was 32, xref accessed value was 77, and x value 77. So this is a reference. It is kind of similar to a pointer, but not exactly similar. It gives access to the memory space, ability to change the data itself, but the syntax is better in this case. But in the case of pointer, you need to be careful about doing dereferencing properly. But pointer has more power than reference, because you can carry the address, you can use the address, you can increase. For example, in this case, you were able to use the pointer to iterate through the elements of the array, but you can do that through the reference.